Okay, now we need to be able to divide the fractions. Actually, we never actually have to worry about dividing fractions. So fractions, as it turns out, will destroy lives. Fractions have destroyed many lives. Division also has destroyed many lives all on its own without being with fractions. But now we have fractions divided by other fractions, which can destroy lives. But if you look back at our last lesson, which was multiplying fractions, then this dividing a fraction stuff, at least when we just get to the pure math part of it, it goes very well. There's just one extra thing we have to do, and then all we're doing is really multiplying fractions. So dividing fractions says, really, can you multiply fractions? And then one other thing. Now the foundation of division, of course, our vocabulary, dividend, will be divided by a divisor, and then it will equal a quotient, and that's good. The dividend is the amount to be distributed, right? This is how much you're splitting up, and the divisor tells you how many groups you're splitting up into. So really it's asking how many divisors go into the dividend, and that's a fair question if you can remember it. Yes, it's okay to have remainders, that's all right. We may see some of those, but actually you probably shouldn't with these problems, because if we have a remainder, it should be included with the fraction, or maybe we change it into a mixed number, which will include the remainder too. So on the assignment, you're going to see problems like this one. 5 divided by 1/2 means, so that's asking how many, that would be the divisor, which is 1/2. How many halves are in the dividend, which is 5? Now that would tell us what 5 divided by 1/2 is. So how many halves are in 5? Well, what we can do is we can take, I'll use a rectangle because they're fairly easy to work with. If I took that rectangle and I cut it in half, then one of those units would have 2 of the halves, right? But what we need is 5 of those. So let's make 5. All right, there's my 5. Well, how many halves are there? Well, there's 2 in each one. You could just count them if you wanted to. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of the halves. So that means how many halves are in 5? 10 of them. Well, what you could have done, some of you may have noticed this, that you had 5 groups of 2, and really it becomes 5 times 2. So this is kind of front-loading on why we need the multiplication down. So this problem right here, 2/3 divided by 1/9, is asking how many ninths are in 2/3. So it may help to put together a little diagram for us, right? So let's say this is a whole, and then we'll cut it up into thirds, and we'll pretend like my drawing's good. Okay, so we take 2 of the thirds. That's what we start with. That's the dividend right there. And we're going to split it up into ninths. Then we'll see how many ninths fit in, okay? Now, how big is a ninth? Well, it means that we'd have to take each of these pieces and split it into thirds as well. So 1, 2, 3, 4, 5, 6. And then if you count these, there's 9 pieces now. So the full piece that we started with has now been split into ninths. Well, how many of the ninths are in the 1/3? So each of these rectangles represents a ninth. There's 1, 2, 3, 4, 5, 6. So in terms of ninths, how many ninths was it? Well, as far as I can see, 6 of them, which means that your quotient here is 6. Now, that's using a diagram like I just did, and if you need to do that, then that's okay. Of course, it may become impractical with some of the values we're going to be using, which is why we need sometimes to just look at division as multiplication instead. But as it turns out, before we can look at the multiplication of the fractions or changing it, we need to know what a reciprocal is. A reciprocal is going to flip a fraction. So if you had a over b, its reciprocal would be b over a. Or if you started with this fraction, you can flip it this way. It doesn't matter which way you go, as long as you're flipping the fraction. It is reciprocating the fraction, which means that, for example, if you started with a common fraction like 1/2, you could change it into, well, it would be 2 over 1, which really is just 2, and that's okay. Or if you wanted to, you could go this way and say 2 over 1, I would change into 1 over 2. So for these ones, we just want the reciprocal of each of these. So we'll start with 1/3. let's go ahead and flip it. So the 3 on the bottom becomes a 3 on the top. The 1 on the top becomes a 1 on the bottom. And I'm just going to simplify this as 3. I don't know that that's necessary on an assignment, but simplified is 3. 9 over 5. Let's go ahead and flip that one as well. So this one, still a fraction, but the 5 on the bottom becomes a 5 on the top. The 9 on the top becomes a 9 on the bottom. This one cannot be simplified. Okay, how do you flip a 17? Well, we make it over 1 because that divide by 1 was always there. That's the identity property for division. But I can flip that. The reciprocal would then still a fraction, but the 1 on top, 17 on bottom, it flips. So if you can understand this with all of these, including the whole value, then as it turns out, you should be able to divide fractions by multiplying the fractions. So this is how it works. What you do is you have two fractions right here. You got the first fraction, which is a dividend. You have the second fraction, which is a divisor. You take the divisor here and you flip it, but by flipping it, you give yourself a multiplication problem instead. And as much as people hate fractions, generally, they would not like to see this, but if they saw this one, they'd be like, okay, I can do that. Now, once you get into multiplication, you should look for any simplification that can take place. I'm not saying there always will be simplification, but you should always check to see if they can be. Now, what it's saying here as well is that sometimes you'll see this fraction or this one, maybe it can be simplified. And if it can, you should. So, we never actually divide fractions. We only multiply them by changing the division into multiplication. It's just that to do it, you have to flip the divisor, and then that changes the operation to multiplication. So we're going to do that with this one, and then as we change it into multiplication, we'll see if it can be simplified. Okay, so what I'm going to do is I'm going to change this into a multiplication problem. Changing division to multiplication will never affect the first fraction, which we're going to call the dividend. But that second fraction, 24 over 7, well, we're going to take that and flip it and make it 7 over 24 instead. But by doing that, we take the division here and we switch it into a multiplication. Okay, well, that's pretty good. And is there any cross simplification that's possible here? As it turns out, there is. And so I'm going to look at this as one full fraction multiplying top and bottom. And now I can see values that will simplify, specifically the 3 and 24. They're both divisible by 3. So 3 divided by 3 would be 1. 24 divided by 3 would be 8. And yeah, I do not see any more simplification that can occur. So I take the two numerators, 1 and 7, and multiply them to get 7. And I take the two denominators, 5 and 8, multiply those to get 40. And yeah, the last thing I would do is just check to make sure these cannot be simplified. And they're not divisible by the same value to be simplified. So this one's complete. Same thing with this one. Well, it is division, and that's okay. Now, some of you would notice the 10 and the 30. Some of you would say, you know what, I can take those and just simplify that into a 1/3. Let's say that you didn't notice that because at this stage, probably a lot of students don't. That's okay too. But we're going to take these values and we're going to take the first fraction, the 12/5, and it's just going to stay 12/5 because that is our dividend. So you can even put an equal sign here. But the 10/30, the divisor, we're going to make it a fraction, but we have to flip the value. So now the 30 becomes on the top, and the 10 changes on to the bottom. Now, by flipping that fraction, we are allowed to take the division symbol and make it a multiplication symbol now. Okay, so we did flip it. Okay, is there any simplification? Sure. I can take those zeros and make it a phantom 1. Is there anything else? Well, it looks like there is. It looks to me, and there's two ways you can do this, but I would look at the 12 and 15. Both of these are divisible by 3. So 12 divided by 3 would be 4. 15 divided by 3 would be 5. And then I'm just left with these final values here. And yeah, you could have made that just like I did on that last problem. If you wanted to, you could have made that just one fraction like this. Either way, It doesn't matter, we're going to get the same answer. So in the top, I now have a 4 times 3, which is going to be 12. And then on the bottom, I've got 5 times, that's 5 times 1, which is 5. And as it turns out, I don't see that that can be simplified, so that's complete. Well, let's go and divide this one as well. So we're going to take that 9/5 again. That's not 9/5, it's 9/20. And I'm just going to keep it the way it is. Be careful, because in the beginning, some students would say the 5 and 20 can be simplified, and the 9 and 12 can be simplified. But you cannot do that, because it's not a multiplication problem that you can divide those by. So what we're going to do is we're going to take the divisor, the second fraction, 5/12, and we are going to flip it into 12/5. That's reciprocation, and in doing so, we take that division symbol and change it into multiplication. Now we can just cross simplify. So, for example, I would look at the 12 and 20. They're both divisible by 4 because they're both multiples of 4. 12 divided by 4 is 3. 20 divided by 4 is 5. And I don't see any cross simplification that can occur. We'll check on our final answer, though. So in multiplying, we should get a final answer here. In the top, we got 9 times 3, which is 27. In the bottom, or denominator, we got 5 times 5, which is 25. I do not see that can be simplified any further, which means that is done. So we saw a few slides ago that sometimes you're going to have to reciprocate a whole number. And if you see a whole number by itself, you're going to need to make it over 1. Okay, so let's say you started with something like 14. Okay, well, if it's being multiplied by, or I'm sorry, if it's dividing a fraction, it may be helpful to see it as 14 over 1 instead. Because let's say that you had something like 2/3 divided by, we'll just say 7 this time. Well, if you make it 7 over 1, now you can flip that fraction, and then you have 2/3 instead of it being divided. Now you can flip that 7 to be 1 over 7 instead. And then you can change the operation to multiplication. See that? Then you got some multiplication involved. You get 2/21, you'd be done. So if you see that you're dividing or either with or by a whole value, like we see here, that's why we need to see this, the identity property of division, which we saw already when we were reciprocating those. If you need it either way, like let's say this number was a whole number, okay, when you multiply it still may be helpful to see it as a fraction. We'll see. So here we go, 8 divided by 4/3. Yeah, well, I don't like to divide with fractions. Maybe you do, and if you can do that, that's great. But I'm going to keep the 8 and 8. But what I'm going to do is I'm going to take the 4/3 and flip it into 3/4 instead. And in doing so, that takes my division symbol and changes it into a multiplication. Okay, well, 8, this is like 8 groups of 3/4. So what I'm going to do is I'm going to make it 8 over 1. And now I can cross simplify with, looks like the 8 is divisible by 4, and the 4 is divisible by 4. So 8 divided by 4 would be 2, 4 divided by 4 would be 1, and now our multiplication problem just was made a lot simpler. In the top, you got 2 times 3, which is 6. In the bottom, you got 1 times 1, which is 1. Ultimately, I'd say, you know what, let's take that 6 over 1 and just simplify it into a 6 and call it good. And that is good. That's all we need to do. Now, let's say that you did not simplify right here. By multiplying, you would have then had 24 on the top, and you would have had a 4 on the bottom, which still, 24 divided by 4, as it turns out, you still would have gotten the 6 right there. So this one, 5/6 divided by 9, and the 9, yeah, I would like to see that as 9 over 1 so that I can reciprocate it. And that way, when I'm dealing with the fractions, I can change this to multiplication. So I've got my 5/6, but I am going to be flipping my 9 over 1 into 1 over 9, which allows me to take my division symbol and change it into multiplication. Now, if there was any cross simplification that I could do, I would, but I don't see any. So It's going to multiply numerators and denominators. In the numerators, 5 times 1 is 5. In the denominator, 6 times 9 is 54. So yeah, 54 is not divisible by 5, and 5 is only divisible by 5. So that means we have, in fact, found the solution, or the simplified form of 5/6 divided by 9. But again, the idea here is that you see when you have whole values like this, just make it over 1. That's the identity property for division, which then will allow you to flip it if you need to, or even just look at it as direct fraction multiplication. And from time to time, you may have to divide many numbers, and we'll see this on the assignment too. But if you do, what you can do, of course, the first value, which we'll still consider the dividend, stays that value. All the remaining values that you divide by flip. See that C over D becomes D over C, G over H becomes H over G. And by doing so, you can just do straight multiplication. So that's what we're going to do. You can, if you'd like to, work from left to right. But if you know that you can just change this to multiplication by flipping these fractions, then you can do some cross simplification. Even if they're far away, like the A and G, you can simplify those, or H and B, or D and B, and H and C. So many, right? So look for that cross simplification once you flip these other ones by changing your division into multiplication. And here's our first example then. We got 1/3 divided by 11/8 divided by 1/5. So my first fraction, 1/3, yeah, it's going to stay 1/3, right? But what I will do is I will take the 11/8 and I will flip it into 8/11. And I will also take the 1/5 and change it into 5/1. Doing this allows me to look at all of the operation as just direct multiplication, which is great because I would like to see that as direct multiplication. Now at this point, we should look for any simplification that can occur. You could say the ones can divide by each other, but 1 divided by 1 is 1. You just keep having 1 going on. 3, you can divide with the 8 or the 5, and same with the 11. So as it turns out, this one, there is no simplification that can occur, which means we're going to go straight into multiplying numerators and denominators. So here, 1 times 8 is 8, and then 8 times 5 is 40. That's our numerator. And then I like to work from left to right, but 3 times 11 would be 33. 33 times 1 is still 33. And now we have, again, this is simplified. We knew it couldn't be simplified because of back here, but I would still check. 33 is divisible by 3 and 11. 40 is divisible by none of those, so it is just complete. So for this, we're looking at more or less or equal, just like we did with the multiplication lesson. It's just that it's kind of switched. Okay, so if your divisor, and we're specifically looking at the divisor, if your divisor is less than 1, then the quotient will be bigger than the dividend. That's important to know the difference between the two. We're always going to be comparing these problems to the dividend always, right? That's what it's saying here and here as well. Now, if the divisor is less than 1, that means that you would be looking at a proper fraction. So that that would mean that the numerator is smaller than the denominator, or you could say that the denominator is bigger than the numerator. It doesn't matter. And then down here, if the divisor is more than 1, that means that you'd be looking at either a mixed number or an improper fraction. Okay, so that's just identifying the values that were already in these statements. So let's look at the statement themselves. If the divisor is less than 1, then your quotient will be bigger than the dividend. Okay? So if we have a proper fraction here, then our quotient will be bigger than the dividend. And the reason that is because it will take many of these divisors to make a dividend. But if the divisor is more than 1, so if we got a mixed number or an improper fraction in our divisor, then the quotient will be smaller than the dividend, because we'll take less of these divisors to make a dividend, okay? Or you could say that, look at it like this. The smaller we make the divisor, the less we have to split up the dividend. Or the bigger the divisor, the more you have to split up the dividend. And that's, it doesn't matter how you're looking at it. Both of those are true. All of that is true. Just go with the one that works best for you, all right? So our 12 dividend on this one, it says without doing the calculation, no problem. But we're always going to be comparing a dividend with a quotient. They didn't say quotient, but it's an answer right there. Okay, so this problem, the main focus is the divisor, which is 7/11. Well, last time I checked, that right there is a proper fraction, which means it's less than 1. Now, less than 1 means that it would take, by dividing 12 into a smaller value, we get more. Everyone gets more, which means that this one would be a more than case. Okay, so, and again, this will be true for any dividend that's a proper fraction. If you divide by anything less than 1, you get something bigger than your dividend. And then this example, once again, our dividend is 1/2. We're comparing 1/2 with the quotient, which would be the answer to this division problem. So all the focus comes down to the divisor. Okay, well, that divisor, 15/11, yeah, that's an improper fraction. So its overall value is more than 1. So this means you're taking 1/2 and you're splitting it up into a lot, which means that ultimately we would expect each group to get less than whatever you start with. So this being 1/2 doesn't matter. It could be a big number, it could be a small number, it could be a fraction. Doesn't matter what you have in the beginning. If you divide it by lots of things, you're going to get less than. The more things you divide it by, the less each group will get. So that completes 2.7, dividing fractions, and hopefully you feel pretty good about dividing fractions. And then also knowing, again, we didn't do any calculations on those last 2 slides, but just knowing based on the divisor, if your quotient will be bigger or smaller than your dividend. That's it.